From punch cards to AI co-pilots, programming languages didn't just evolve. They rewired how we build the world. We'll race from BASIC to Mojo and show how each language unlocked new superpowers: speed, safety, scale, and real products you use daily. Era 1. The foundations, 1960s to early 70s. BASIC democratized programming, simple syntax, interactive RPL, line numbers. Benefit: low barrier to entry, millions learn to code. Real-world examples: education, hobbyist era, later inspired Visual Basic for rapid form apps. Unknown bit, designed for time sharing so many students could code on one machine. Fortran, 1957. Features being built for numbers, compiled speed, first-class arrays, and some of the earliest code optimizers. Benefit being speed on limited hardware. Real-world examples: simulations in physics, climate, aerospace. Still runs in high-performance computing. Lisp, 1958. Features: code as data, macros, garbage collection. Benefit: expressive AI prototyping. Real-world examples: early AI systems, rule engines, compiler research. COBOL, 1959. Features are English-like records and files. Benefit: business data processing at scale, legendary longevity. Real-world examples: banking and insurance mainframes still depend on it. Structured query language, SQL, 1974, 1970s. Features are declarative queries. You say what, not how. Benefits being productivity and data independence. Real world, powering every relational DB behind your apps. Era 2, systems and paradigms, 1970s. C language, 1972, gives you raw pointers, hands-on memory, and near-metal speed. Portable assembly for the real world. Benefit being near-metal performance and portability. Real-world examples: OS kernels, DB engines, embedded game engines. Unknown bit, C language. Existed to rewrite Unix in a portable way. Pascal, 1970. Strong typing, structured programming. Benefit: teach correctness and structure. Smalltalk, 1972. Pure object-oriented programming, model view controller, live development. Benefit being invented modern GUI and ID ideas. Prolog, 1972. Logic programming. Tell it the rules, let it find the answers. Benefit being declarative problem solving. Scheduling, expert systems. Era 3, the web and scripting boom, 1990s. Python, 1991. Clean syntax, batteries included, massive ecosystem. Benefit: developer speed, glue across domains. Real-world examples: artificial intelligence, machine learning, automation, web, DevOps. Java, 1995. Java virtual machine, garbage collection, strong typing, huge tooling. Java powers enterprise scale, portable on the JVM. Massive ecosystem, rock solid in production. Real-world examples: banking backends, Android applications, big data. JavaScript, 1995. Prototype-based, event loop, runs in browsers, then Node.js. Benefits: universal client runtime, full-stack reality. Unknown bit, created in 10 days to ship with Netscape. PHP, 1995. Rapid web pages, easy deploy. Real-world examples: WordPress, news, e-commerce. Ruby, 1995, and Rails, 2004. Elegant object-oriented programming, metaprogramming, developer happiness, startup speed. Real-world examples: SaaS Wave, many unicorn MVPs. R language, 1993. Vectorized stats. CRAN, Comprehensive R Archive Network. ggplot, a popular R plotting package implementing the grammar of graphics. Benefit of R language being stats-first workflow. Real-world examples are biostats, finance, academia. The 90s turned computers from corporate tools into the world's connected canvas, and scripting stitched the web together. Araquat managed multicore and cloud 2000s. C#, 2000. C# runs on .NET, types cleanly with generics, queries data with LINQ language integrated query, and goes concurrent with async sock await. Benefit being productive enterprise and desktop development. Real-world examples: Windows apps, Unity scripting, services. Scala, 2004, FP, functional programming, plus object-oriented programming on JVM, concise yet performant. Real-world examples: Apache Spark pipelines, microservices. F#, 2005. Metalanguage, family functional programming on .NET, correctness and interop. Real-world, finance modeling and data science, built right on .NET. Go, 2009. Simple syntax, Go routines, channels, fast builds. Benefit, concurrency with minimal fuss. Real-world, infra, microservices, Kubernetes tools. This set the stage for safety at speed. Era 5, safety, mobile, and AI tooling, 2010s. Rust, 2010. Ownership and borrowing, zero-cost safety, no GC. Benefit, memory safety with C++ class performance. Real-world examples are browsers, crypto, systems, backends. Kotlin, 2011. Null safety, coroutines, concise JVM interoperability. Benefits are fewer bugs, faster Android development. Real-world examples: Android and server applications. Swift, 2014. Keeps you safe with optionals, fast with value types, and flexible with powerful generics. Benefits are safe, fast native Apple development, across Apple platforms. TypeScript, 2012. Static typing atop JS, stellar tooling. Benefits: scales front-end and Node code bases. Julia, 2012. Compiles on the fly, chooses the right method automatically, and flies through numbers. Benefits: Python-like ergonomics, C-like performance. Elixir, 2012. Gives you Ruby-like elegance on the Erlang Beam VM, with lightweight processes, supervisors, and OTP patterns for fault tolerance. The stuff telecoms use to stay up. Benefits: friendly developer experience, resilient web and event systems, real-world real-time chat, fault-tolerant web event systems. Dart with Flutter 2011-2017 compiles just-in-time, compile for fast development, ahead of time for speedy applications. Everything runs on a reactive UI. Benefit: one codebase for mobile, web, desktop, startup to enterprise. Real-world examples: Flutter ships one codebase to iOS, Android, web, and desktop. Fast for startups, proven at enterprise scale. Modern languages prioritize safety, developer experience, and acceleration. Right now in What's Next, 2020s. Mojo, 2023. Python-like syntax with static specialization, MLIR, and accelerator paths. Benefit being Python ergonomics with near CUDA, compute unified device architecture, performance tracks. real-world experimental AI/ML kernels and high-performance numerics. Built for pushing AI kernels and crunching numbers at blistering speed, WebAssembly First Languages ships safe, portable binaries that run fast, browser or server, same file. Benefit being polyglot web beyond JS, real-world plugins and edge compute, NIM, Zig, Crystal, rising niches, simple systems programming, predictable performance, native binaries, used where control and clarity matter. The pattern? Each generation solves the last mile. Access, performance, portability, productivity, safety, acceleration. How to choose? Pick the tool that matches your constraints. Latency, scale, team skills, ecosystem libraries, and deployment target. Start with the outcome, then map to strengths. Constraints choose the language, not the other way around. If this tour clarified the landscape, smash that like and subscribe. Drop a comment with your favorite programming language.